So, hello everybody, warm welcome to new session of Holochain in Action. It is a virtual weekly meeting running by Holochain community members. So each and every week we are gathering and talking to each other about the Holochain application, technology. So, and if there is something, good content, also we press the record and share the video via YouTube to you that you can also see what's happening inside the meeting. For sure, the meeting originally is longer than the recorded version. By the way, if you would like to participate, if you believe you are a app designer, architect, or you would like to share something and you would like to join this meeting, please go to the description and fill out the application form. Also, in the forum.holochain.org, there is a section for these videos. Please give us feedback and let's see how we can improve the content, or if you are looking for a specific, we can talk about that. And especially if you are from other communities, other projects, and you believe we can create a bridge between our community and to see what our potentials are there for any kind of communication, any kind of bridging, a project collaboration, please warm welcome. We are waiting for you here. So, and if you are invited, we are going to see you there in your community. So, by the way, all the link, repository, anything that we are talking during the session, you can find in description. That being said, and thank you to everybody that joined this meeting. So this session, it's all about countersigning. So what is the agenda? We are going to talk about this topic, countersigning or multi-signature entry. What is that? Why we need it? When we can use it? What is the purpose generally? Then we are going to take a look at the code repository, and then we go to the sequence diagram so that you see how the things are working. And then we go deeper and deeper with a bunch of questions. So if your need is enough and to see one example, that's enough. There is no need to go for a lot of detail. So that's being said, from me, let's go and hear from Guillaume. After solution, let's ask my question that Guillaume just easily continue. Hello, Guillaume. What is countersign?
Hello. Yeah, very glad to be here again. So, countersigning or multi-party entries, or yeah, I think those are the two only names that we refer it by, is a mechanism built into Holochain. Actually, in the last, I think, in the last 4 versions, it's somewhat recent, right? It's a built-in mechanism to create entries only if n parties agree to it, right? So it's a way to say, okay, I promise to create this entry if all of the people in this meeting also promise to create it, right? It's a very useful mechanism in Holochain. It's somewhat redundant in the sense that you could build it if you don't exactly, if it doesn't match exactly your expectations or your needs, you can build the same thing with your own mechanism, but having it baked into core makes a lot of things much easier to do than before. For example, typical classical example of Holochain is mutual credit system, right? In a mutual credit system, I have to transfer some credits to HiA, and this is a transaction, and the most important thing about this transaction entry is that the time at which he does the transaction and I do the transaction is recorded. Why? Because that time and that let's say location in the source chain of both HiA and me will determine whether that transaction is valid or not, right? Because the transaction depends on all the previous transactions that me and HiA did, right?
So to clarify right now, before going to possible scenarios, this countersigning so far, when I'm publishing something in DHT, so we all know that if the data is private, for sure, one piece of as an element is going to be source chain. Source chain, it means the stack of the data based on the sequence on my local device, and we have a DHT. If it is a public, the content is going to be in the DHT, and also the header or the action is going to be in a DHT. So, because it is coming from me, my signature is enough that I can prove I did that data as a provenance. In the countersigning, there can be a bunch of scenarios that I would like to say Yost or Shane or Tom or Guillaume here, or all of us or one, two of us. We need to put something in DHT, but both of us should agree upon that topic or a fact. So I'm signing something, you sign something, and then go to the DHT. So, and also at the same time, we need to put two elements in our local source chain. So all in all, it means it is generally a process. It's creating a session. Some handshaking is happening. The whole thing is happening inside that session. That the handshake is happening. I'm sending and receiving something. You sign something. I sign something. When they are equal and valid, we put in the DHT and we finish the process. That's it. Can I say it is?
Yeah, exactly right. Just a comment, which is in Holochain, you encounter lots of times this problem of eventual consistency, and we can know for sure if this event happened before this other one or whatever. Countersigning is the only way that we have to make transactions across multiple chains, right? So it's like a source chain, a normal Holochain source chain, it's like first element, then second element, and you can't assume anything about another source chain, right? So another agent, it's their own elements, like they have no particular order between them, right? It's like you don't even know. But countersigning is a way to have like transactionally, not only transactions, transactionally atomic cross-chain transactions, which is really important in a lot of edge cases, right? It's not, you won't need this for 70, 80% of Holochain applications, but there are some use cases which is essential.
Got it. Let's see, let's go to some example that, hey guys, any question you have, please jump, okay? Please jump, do not wait. For the more detailed, complex question, how the things later, but about the scenario example, please jump. Let's see what use cases to see when we might require this one, okay? We are going to talk about what we have in a DHT or what we need to implement as a developer later, okay? But right now, use case. For example, I always was thinking to implement kind of a employee-employer contract in the Holochain, you know? So I was thinking, okay, this kind of contract should has the signature of both sides, okay? So it means I cannot put something in public environment named DHT with the contract, put something in my private source chain. Hey guys, when we are talking about the source chain, it means the chain of data which is on your devices. DHT, it means public space. So, and then I ask another one, go and confirm that one, you know? It means it doesn't work. I can easily say the countersigning is totally valid for me. I'm going to be employer, GM is going, or Yas is going to be my employee, or vice versa, anyway. So there is a contract. I can say, hey, I'm ready to work for you with this condition, blah, blah, blah. It is my signature. I'm sending to you, you sign it, we put in the DHT. So, and we can defense on it in any court because both of us sign it. So nobody can change it. I can say it is one of the places I can see a use case. Another one, transaction, as Guillaume mentioned, mutual credit, because I need to agree if somebody giving me something, or for sure I need to agree when I'm sending my also. It means, hey, there is a transaction, you agree, I agree. So we sign it, we put it. What else? Good example.
I think the example that we are going to review, ELOs, are a really cool one, actually.
Give the title, please.
Right. So we implemented ELOs in elemental chess. ELO is a rating system, which is basically you have some points, right? So everyone starts with 1,000 points. And if you win a chess game, you receive some points. If you lose the chess game, you lose some points. And there is some simple mathematics for that counting system. But the important part is that both parties have to agree, right? So it's interesting the way that this happened before. I was thinking to implement ELOs without countersigning, but I was running into all sorts of problems. I was like, wait, what if me and Hedayat are playing a game and then we commit without countersigning, and then me and Just are playing a game and it's without countersigning this scenario. What if I can say to Hedayat, hey, this is my ELO, without Just knowing about it, and the same with Just. Now I have a way to cheat, right? And like I can do that if I lose for both of them, right? And now I have a way to not lose as many points, right? So what thinking about solution and so on. And in Holochain, we always ask, how do we do it in the real life, right? So chess tournaments, you go there, and I actually have a friend, close friend, who lives in Barcelona, who is like a FIDE certified chess player and so on, and he brings us these little papers, the tournament papers, right, which is with all the moves and so on. So what they do is both players keep account of every move of the game, and at the end, both players sign both papers. So both agents have proof about both players agreed on the result. I was like, all right, that's countersigning. Yes, exactly, that's exactly right. And then everyone walks away with their own copy of that, right? And if some of the agents don't want to sign because they have lost, then that's a clear bad agent behavior, right? In this scenario, I couldn't enforce it with validation rules, but it's more about the social process. So if you see a player who has a lot of game results unfinished, okay, what's up with that? Like, check, could you whatever process, right? This was a bit the story and the process.
Amazing. Generally, again, like always, we come back to the social fabrics. So in the peer-to-peer, there are a bunch of scenarios. Two sides should go to agreement to do something. So right now in the centralized world, anything you see, for example, in your bank account, there is another third party confirms something on behalf of you. If you receive a transaction, if you receive a money, actually you should confirm that, but right now you don't feel it because another party do it on behalf of you. So it means always we need a two-side agreement. But right now in the current world, in the current centralized world, part of it is hidden because another party doing on behalf of us. It is a reality. But in the Holochain countersigning, it is. Yes, do you have a question? I saw. Okay, that's it. That's it. We are going to look.
That was my agreement to just. That was a great insight. Thanks.
You're welcome. About the part of always two-side bank, blah, blah, blah. Yes, yes, it is. Please take a look at all the systems that you believe you don't need to be there. Generally, you need to be there. You need to agree upon something, but there is another one giving you a tick on behalf of us, especially in banking and transaction. I gave this example as a purpose because a lot of people coming to the peer-to-peer distributed, especially Holochain, asking, oh, why I cannot do transaction when I'm not online? Because you need to agree. But in the current version, it means the current life. Another party do the agreement for us, and that's why we don't need to be online. So bank is confirming on behalf of us. So that's being said, we are going to read the code. Please take this short description, keep it. We are going to open it. How much functionality of countersigning it is in the core, Holochain core, and how much it is there. There is a little bit of explanation here because everything is not supposed to be in the core. The core is supposed to provide a basic implementation and facility, like giving you a piece of Lego, and you are as a developer supposed to put this piece of Lego and connect them together to create your countersigning scenario. Because when we jump into the sequence diagram, you can do in this way, you can do in that way. At the end of the day, you will reach your countersigning, but you can play with this piece of Lego, okay? No more detail. Let's jump into the code. We will come back to this section, which is really important, and we will show you where to find and how to. Are you ready, guys? So I'm going to share my screen. Do you see? So first of all, thanks to Guillaume for this Elo that Guillaume mentioned. Guillaume, would you please make a Holochain in action branch later on that we can put in the description? So we don't have it right now. I'm going to put the link to description later on for sure. Guillaume, do a favor for us, create a new branch, Holochain in action. It's going to be on touch, connected to this video. You can go. It is the example about Elo. We are going to read the code, and also let me show you generally how to form just Holochain. You go to the developer. Always, it is the way you go to the core, to the resources or references, sorry. And then you see HTK references, it should be updated. If it is not done fully, you come to this place, go to the latest version. It is all the place you can read about HTK. So we recommend countersigning, for example. Always try to keep your knowledge updated using this HTK. That's it. HTK countersigning. Also, it is the place you can go and read. What else so far? Nothing. I already opened the project. Let's see how to find the project, and we are going to see the sequence diagram. So, like always, if you open the Elo, the project from the root, you see this one, these folders, example, lib, target, test, UI. Like always, I'm opening the target to this cargo tunnel. I see different workspaces. Example is here, profile is here, and lib is here. It is kind of a package that I can see. There are some you can easily search them, optimization level. Anyway, so UI is obvious. Test, we are not going to take a look right now. Libs, it seems it is the place that all this version of implementation is located, but we are not going to take a look. But let's see what is in cargo tunnel. It is enough. And then I go continue to see how it is. In the cargo tunnel of lib, it is the HTK. This is the version. Good. So HC mix in Elo. About this one, we will talk later, don't worry. Third, it is used a skill rating. It is the Elo basic rating. How the Elo is working, I can guess. PM, if I'm wrong, please just correct me.
You guessed right.
So, Holochain, that's it. I'm going to go to the example. For sure, it is the example of the usage of this one. If you always remember work directory, it is the place that zone definition, blah, 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 is going to be here as a manifest, and also HAP. It is the HAP is going to be built as to a slot that it's going to be changed a little bit. DNA that you can see, we are going to have one DNA. So, and it is the zone as an example. So, and also let me tell you, even always when you are reading the code, just a little bit, you can look at my pattern. So I'm coming to package JSON to see what we have. Generally, when you start a project, you build app. What's happening in build app? I select it is here. Build DNA. Building DNA. What's happening? It's a build zone. What's happening in build zone? Build zone is cargo, build target. It is the build command for the Rust for generating WebAssembly. Step by step, start, come, go to the app was here, it was DNA, it is a step by step, see, it is the flow, it is the bubbling up. So this one is building zone, this one then building DNA pack, and then this one is the building app. So this one for a packaging UI, making a zip, and then this package, you can see it is running any command, running a below command here, as you can see. So I can see all about building zone, DNA, create pack, create the UI zip, and run a sandbox. We generated and we had a dedicated session about sandbox. Please go there if you are not familiar. And then yes, bam, anything to going to be ready. Concurrently, these commands are going to be run, one version of UI and app. That's it. Generally, it is the way I start to reading the project when I'm open. If anybody would like to add something else so far, please. Otherwise, I will go to, yeah.
No, just a comment. This structure is what is actually, or at least really close to what the scaffolding tool generates for you. So if you are using that, you're going to be very familiar with it.
That is great. And Guillaume, let's have a talk one day on totally scaffolding. It's great to scaffold the project, to play with it, to play with the tools. Thank you. So leaps from the example, zone example, it is quite easy. So it's imagining like always, we have the entry definition, game, mixing. Elo, it means with this command, which is a macro. So it's bringing all some basic knowledge. We will talk about it later. So, and then what we are doing, attempt, create, countersigning game result. Easily we go inside, we see here, as you can see, we jump into the mixing. Okay? It is selected mixing, coming here, and it is just calling try create countersigning game result. We go back to see what's happening here. It's important. There is a just Elo rating and this one, create game response. Look, the response can be entry hash. It means this one or this one. Either both sides are going to be agree and the result is going to be success. At the end, we are going to have a one entry hash as a result with the two signature. Either there is something right now with this name, but you can have your implementation or anything later on as an outdated result. That's it, generally. So to speed up.
Jump ahead, just you had the question, jump.
Ah,
yes,
sorry,
thanks.
I don't see.
No, fine. All good. Is a mixin here also just a simple copying, including of code? Or what does it do?
Go.
Basically, yes. In general, this ELO module is implementing a whole bunch of patterns. And what we would want to do is explain the countersignature and as minimum as possible to the other patterns to be able to focus, right? Right now, just to give you some context, you can think about this as it was an ELO zone, right? Like the mixing part is just about copying and pasting the zone code somewhere else. So yes.
Okay.
About the mixing, we are going to have another whole topic because it is a kind of pattern that GM started to do not mix the two big topic in the same session or the same content. We are going to talk about the mixing another time, maybe next week, I don't know. But this mixing generally just look at it to bring up the whole functionality to as a library. That's it. For now, it's enough. So, and but the way I would like to just go to the flow that we see how to use it. That's it. That's it. And then we need to go to sequence diagram to unreveal or unwrap the difficulty and the topic. So it's coming to mixing, try create countersigning game result, and then we are coming here and we see that it use game info, opponent address, my score. It means, for example, Alice sent something and they are building something, send publish game result to request. It means the one party provides some information, opponent, blah, blah, sending to another part, send publish game result request, something, and game result pre-flight. Okay, we are going to see what is that one. So, and here after result accept, there is a match. So, and we can see the match can be accepted, or if it is accepted, okay, result, otherwise it's going to be error, it's going to be some result. So call remote result. So I'm going to write now short the reading. Here it is the, I'm trying to understand if it is another layer that we need to go. So accept, yes, it's coming here. The result, it is a create game result outcome. Exactly, it is the outcome we were looking for. It means we reach the end. Okay.
I think it's important, line 61 is also important to note.
Please.
Right.
Wait, let me do something. Let me give you like always the full permission that you can, okay. You can like always.
Yep. So I can summarize, I think. Okay, let's see. Yeah, I can summarize what this is all doing. Like what we want to do with ELOs is, hey, I won the game against you, and we want to publish that result and update both our ELO scores, right? So that's the basic use case. I have 1,000 and HiA has 1,000, and I have to go up to 1,005, and HiA has to go back, down to 995, right? Mm-hmm. That's the use case. Mm-hmm. So first, we get the previous, our previous ELO and our previous information about things to build the entry to be published, right? This game result is the actual entry that we want to create. Mm-hmm. It's not created still. We have just built the data structure about it, mm-hmm. right? What we then do is start countersigning session, mm-hmm. right? Mm-hmm. And lock our chain. We will go a bit deeper in the diagram. Okay. So we have basically signed mm-hmm. the entry, mm-hmm. and then we call our opponent so that they sign it too. I see. And this is a call remote. We are going to see what our opponent does, but when they are done and we get the response, and there are a couple of different scenarios that we have to control here, but this is specific to ELO. I won't get too into it. But if all goes according to plan, at the end, we actually create the entry.
That's it.
Right? So first build data structure, then sign it yourself, locking your chain, then send that information, all that information to counterparty. And when counterparty sends back their signature, create.
I see. I see. So again, let me stop share my screen. Let's go and see the sequence diagram. It was overview. We are going to see the sequence diagram. You can see the photo and before starting, if you have a question, why calling remote or blah blah blah, it is not part of the core. Why it was there? Exactly, it was my point I mentioned. The countersigning, the whole flow, it is not finished and ready as a package inside the HDK as a core, because you as a developer might to play with it, to shape it, to do something. And that's why part of it that it is really important, like locking the source chain, do something, some core topic in the HDK, and the rest we need to do as a developer. That's it. That's why you see a call. Right now, let's go to sequence diagram. Yeah, please.
Yep. Okay. So, laat me maken. Test. Okay, cool. Can you see this? You're muted, Hedayat, but I'm assuming you're saying yes.
Yes, a little bit bigger also would be fantastic.
Like this? Okay, cool. So, we are going to cover two scenarios, a scenario in which Bob accepts and a scenario in which Bob rejects. We have changed the names in this diagram from the actual names in the HDK because we thought that they were confusing a bit. So first we are going to explain the whole flow as it is implemented in ELO. It's not the only way that you could implement this. And then we are going to compare it with the code just a bit, just to like make it work coherently. Okay, so here, Alice wants to publish the game result, right? So what Alice does is first locking the chain. When you are locking the chain, you are committing that the next thing that you are going to be creating is this entry. So here you lock the chain with this entry. You're saying, hey, I'm committing myself. If both of us agree, the next thing I'll be committing in my source chain, it's going to be this entry.
But shouldn't we start from a session info? So what is the session info?
Sure. Yeah, like this is not that important. This is why I like semi-skipped it. Sorry. So session times from millis, this is basically a way to configure your session. And the basic configuration, the only configuration right now that we have is the timeout, right? So you have a trade-off here, which is you are locking your chain for a certain amount of time, maybe 1 second, maybe 2 seconds, maybe a minute. If it's too short of a timeout, maybe it won't be enough for all the parties to gather the signatures. If it's too long, then you're going to be locked, right? Because you're locking your chain. So if it's too long, you're going to be locked, right? So this is what this is doing. This is building a session info from some configurations, right? You're configuring the session, but you're not actually doing anything yet.
That is great. So at first, any countersigning should start with the session. It means if in the middle of any place of the process, the session terminated, we didn't finish, everything is going to be read as a transaction. Undo the transaction. That's it.
Yep.
So, and I can imagine the session also can be dynamic. We can detect how much the network is fast. And if we are in the really high speed network, we can dynamically increase or decrease the session number that we know it is fast. We can say, hey, we can finish it in quite soon. Yeah.
Yep.
Kind of.
Yep. Exactly right. This is one of the things, like to your point that you were saying, you can do very, very different configurations and very, very different flows because the countersigning functions do not decide that for you, right? You have to decide what's the appropriate flow for your use case.
I see.
Right?
Great.
And this is like, you could argue, okay, maybe you can pass here some timeout, or like maybe this is not necessary, but maybe in the future it is, to add some configuration, right? To be able to follow different flows, not this one, right?
Great. Yes.
Okay. So we configured the session. We have session info. We haven't done anything yet. Make it clear. Like, it's very important to know when you have done something to the database and when you haven't. Here, you didn't do anything yet, right? You're just building some configuration. Now you are locking the chain with an entry and session info. This entry is the game result that we saw, but in different use cases must have different entries, right? So this could be a neutral credit transaction, or in your case, HiA, the contract between employee and employer, right? This is arbitrary. So it's a string of bytes as far as Holochain knows, and you can put whatever Rust track you want here.
So can I ask a question?
Yes.
So why do we need to log? Should we review the process and return back, or we can talk? I think we can continue and then ask those questions. Why I need to log the source chain? But generally, local source chain, it is the place that any other activity going there. When we are locking the source chain right now, why? For later, but it means I cannot do any other activity. That's it. It means I cannot publish another thing in the DHT because the source chain is locked. It is the meaning. Why? Let's continue.
Cool. So you are locking the chain, and the same process that locks your chain with the entry and session info actually already signs it for you, right? It signs the entry for you. It's not actually signing the entry. It's always also signing the moment in time at which you are signing it. So this is a signature, not only that I want to commit this entry, but I want to commit this entry now, as opposed to 10 days later, right? That's important in the future. So now you have the entry plus session info plus signature, and we do the call remote that we saw with that information, right?
This box in the left side, it means the rest of the process, my source chain is locked. Yes.
Yep. Yes. So you can see here this box. From this call on, the source chain of Alice is locked, right? If another call comes for Alice conductor, it will be rejected. Sorry, wait. If another call comes and wants to create something, if it's a read call, all okay. If it's a create call, it will be rejected. That's important. Cool. So we do the call remote to Bob and say, knock, knock, Bob, what's up? I want to create this with you. Are you game? Do you want to play or not? And let's say Bob is in a good mood, and they say, yeah, sure, I'll create this entry with you. So they do exactly the same thing. Notice that this process and this are exactly the same, and it's the same call in the HiA. We're going to take a look because we need both Alice's signature and Bob's signatures are different, right? So we have this signature, which is Bob's signature. And now it is only at this point that Bob has both the signature that Alice sent him and his own signature. So he has all he needs to actually create the entry. Right? So the definition of a countersigned entry is that it's an entry that has to be countersigned multiple parties. If you don't have the signature of the multiple parties, you can't actually commit it. And this is the first time, right here, in which Bob has both one signature and two signatures. So he goes ahead and creates countersigned entry with both signature Alice and signature Bob. Notice that here, as we are deciding to implement it this way, we could implement it another way, but here we are locking our chain and immediately after creating the countersigned entry. That's totally fine. And this is basically guaranteed to succeed, right? So there is no doubt that this will succeed. And the lock time is really short. It's a matter of milliseconds.
So, and then we are going to go back. Just review here. Alice and Bob receive. Bob cannot manipulate the data because the signature is there with the hash. It's telling that, hey, I agree upon this data. Bob cannot manipulate the data and sign it because then the hash and the signature is going to be invalid. So it means the process, the core guarantee that Bob cannot change or manipulate the origin of the data, and Bob lock its own source chain and sign it. And right now, Bob has everything to say, create entry in my local source chain and publish to DHT and unlock. Yes?
Exactly.
That's great. So, but the whole session and workflow, still it is not finished. Let's continue.
Right. So now the thing that's missing is that Alice actually also creates the entry, right? So Bob returns only the signature that Bob generated, this one, right? The other stuff Alice already has. And with this signature, Alice can also create the countersigned entry, right? And this is the exact same process. It's important to understand actually that this will generate two different headers, right? So a countersigned entry is like any other entry. Actually, I think it's cool that we divert a bit and explain this, which is, I'm looking at the docs, HDK docs version 115, the entry data structure, right? And we are normally always committing these types of entries, right? But there is a new type of entry, which is a countersigned one. So if you think about it, Holochain core could have gone in different directions in implementation in this case, in this primitive, but they have chosen to not modify the headers at all. The headers are exactly like they were, right? So each header is a create header with the author and only one author. But what they are doing is inside the entry that's being created, they store everything that's necessary to check that the countersigning session was correct. Right? And this is what we see here with the countersigning session data.
It means a part of the data about the countersigning is going to be inside the entry.
Everything about countersigning is going to be inside the entry.
So in that case, how we can fetch, because it's, for example, in my case, and put name inside the entry. So it's going to be hash. So I can say, give me the entry with name in Cordoba. I can always query that one. But if there is extra data like a headers, countersigning, how can I regenerate the hash to fetch the data?
I don't think you can very easily.
Okay, we will see later. Let's go.
Like, I don't think we will see later. You can't easily regenerate the.
You cannot.
No.
So how,
Like,
how I can fetch the countersigning? So in that case,
so you have to link it from somewhere
okay,
or query it.
okay, got the point.
Like, this entry cannot work as an anchor ever,
I see.
right?
I see. Got the point. So continue, please. Then let's go to see what we have in the DHT to see what we have intermediate header. Okay, if you would like also to continue the sequence and also reject, please continue.
Okay, cool. So knowing that this is only a normal entry, well, it's not a normal, it's a special one, but at the end of the day, everything is contained inside the entry. So this is creating a normal entry, which means that it's creating its own header, that it's passing validations, that it's publishing to the DHT, everything that a normal entry does. And this is producing the exact same entry, but with a different header because it's another agent, right? So at the end of the day, what you will find in the DHT is one entry with two headers. And that's totally fine by Holochain. Like, that's a really usual use case. Yeah, that's it. Like, the point is that Holochain core could have gone different ways to implement this, but they chose this one in which headers are not touched, and we are having everything inside the entry, so two headers pointing to the same entry. Any questions about this flow, this particular flow?
Yeah, I have a couple of questions. So how is the agent that initiates this determined? Because if both Alice and Bob say, hey, the chess game is done, I'm going to start the process. We both lock our source chain. We both try to talk to each other, but we're both locked. Like, how does who goes first?
Right. In my implementation, that was really easy, which is the guy who won.
Okay.
Initiates. So
Great.
it's a convention, really. But in other use cases, mostly when there is conflicting interests, you could be a bit smart about that and say, okay, either one of those can initiate it, but before initiating, they have to check, right? If there is already a session in like an ongoing session or whatever, right?
Right.
But in this case, like I went the simple route. Right.
Cool. The next one is if the signature Bob call fails, I imagine there's just some kind of timeout to unlock the initiator source chain.
Yeah, exactly. Yeah. This is the session milliseconds. It refers to the timeout time. So the timeout is basically if in this much time I have not committed the countersign entry unlock, and the whole process is done. Basically.
Right. Okay. And the last question I have is around the private public nature of a countersigned entry. My understanding coming into this is that all this stuff happens on source change, but right at the end there, you said that you have two headers and this countersigned entry gets published to the DHT. I'm wondering if you can clear that up.
That's a really good question. Countersigning being another type of entry, that can be private as well.
Okay, so you just determine where you want to save it.
Yeah, exactly. Yeah. And this is one of the things about like HiA's point of you in your use case can decide. So maybe it's not as powerful in some cases, but in some cases you want strong privacy, so you don't want to be publishing. Maybe a employer-employee contract is a good example of that. And the important part about being a countersigned entry in that case is that when needed, both the employer and the employee can demonstrate that the other party signed that contract at some point, right? This is like the two chess players walking away with their own copy of the little paper, signed, right? It's not published anywhere, but if at some point there is some problem, anyone can go and say, hey, like, they signed it, right? I have the copy here, right?
Cool, that makes sense. Thank you.
Cool. Go.
Sorry, yes, I was doing something. Would you please stop sharing? Let's do something because I love this question. So came to my mind that let's make it a little bit detailed here. It's really important to give the image what's happening. So somehow you can countersign on something, but the content should be hidden. But we can have a footprint that, hey, Guillaume and I agree open of something, but the content is private. But we sign on it, we can put the signature on DHT. So am I right, Guillaume? So we can also do this scenario.
Yeah. Although interestingly, the header is already signed. So you create, imagine, private contracts, right? And we want the contract to be a countersign entry and contain both our signatures. The header will always be published.
For sure.
And the header will contain the signature of the entry hash.
Yes.
Right? So that's already there.
Yes. So to clear this one, I would like to say, can we play with this one? So it means really quick, it was Alice and Bob that started this topic, Alice and Bob. So to just bring the imagination. So here it is locking the source chain. It means, hey, the source chain is locked. I'm going to create a new entry. So Alice is making a session. Let's do this one. It is a session that Alice starts back. So, and then it is the session, and Alice is telling, okay, it is the entry or data I would like to sign, and it is my signature. So, and then sending this one to Bob, and Bob, it's making the lock here. Say, I'm locking my also chain. So it is good. And also I'm adding my signature here. So entry signature, Alice A signature, it is a signature A. So Alice and signature B. So adding here as a new chain and unlock, then unlock, adding here as a new one. So let me imagine it is the end. And then it's going to publish to DHT one entry as a content entry that is contain the data that Alice wanted to have and the data of signature of Alice and Bob. And also because Bob published, we are going to have a one header that it is header. It is telling that this header, it is Bob create this entry. That's it. And then Bob telling, hey, I'm finished. Alice, I'm finished. And it is my signature and use it with my signature. It is signature B. And then Alice has everything, entry, signature A and signature B. And Alice is going to publish in DHT because the entry is the same. It's not going to be duplicated. We are going to have another header for Alice that both of them referring that they create this one. And I forgot to mention that Alice is going to put it here, unlock, and we are going to have a two header, one entry because the hash is the same. So far, so good?
Yep.
So
Yep.
the topic that if we are going to have something confidential, some private country, so content, when Alice start this topic, Alice, how we can put this one, it means as a private entry, private contract or something. Inside the header, these two header can refer to the element inside the local source chain, yes?
Yeah.
And based on the header, it means we can remove the entry here, the content here. So we just hash of the, for example, we can put the hash of the content here instead of the content.
No. Like everything is the same, except that at the end you don't publish the entry. So if you remove that entry from the DHT,
okay, it's going to be private here. I see.
And that's it. And everything else is the same.
I see. It means we are going to, this one is not going to publish because it's private, but because we have it here and here, both header are kind of connected to the private topic and we can follow them up. That's it. Okay, that's clear. I hope this.
And in this last scenario, can Alice not publish something else? Can she not just publish something else instead?
The whole.
And I'm not publish, I mean in her own source chain, can she not write something else that she wants to?
The signature is going to be invalid.
Right, yeah.
The signature you put inside is going to be invalid. Go ahead.
So the header contains the entry hash, right? And the entry hash for both have to be the same. So imagine if Alice was to create a private create header with a false entry hash and publish that. The validation rules for that won't fail. Like it's a create, okay, it's private, you do you, but then the social coordination, the social practice can be, okay, go to Bob. Bob says, no, look, I did this with Alice, and Alice promised to do it at this header hash, at this moment. And then we go to Alice and say, okay, at this moment, and then next, wait, it's not the same entry hash. We know the entry hash because Bob just told us, right? And Alice agreed, like the promise that Alice did is about that entry hash, right? So we say, Chiche, Alice, Chiche, no. This is interesting because there is no way that you can do it at the Holochain level because it's about validating private entries. That's really not possible. But at the social level, it's you have a very, very clear way to detect it, right? A really clear way to prove that you did the right thing, really a clear way to detect that someone did the wrong thing.
Right now, quickly, we can also review why in a countersigning, we are locking the source chain. It means why the process will lock your source chain, because when the header is supposed to be connected, so the sequence of the events or elements in your chain is a matter, and also it's connected to header hash. And I believe it is the main reason that we need to lock and you commit that, hey, right now I'm in a business with you right now, not the business of money, it's the job in the process with you. So, and I commit to the fact that I'm not going to do any other action. I'm in this state. So when our job is finished, so I'm going to put this one element in my local source chain and publish the header. If it is public entry, also the entry in the DHT, and then it is finished. So the main reason that why we lock the source chain, please again correct me if I'm wrong. So that's because the sequence of the things and header are matched, and so during the time, so the way that the headers is going to refer to the previous one, it should guarantee that yes, I was here, I made a deal with you, I was not talking or cheating or something to anybody else, we finished our job, go to the next step. It is the main reason for lock. Again,
yeah, exactly. I want to give an example, like what would happen if you didn't have locking, which is, imagine a mutual credit system where credit limit is -10, right? So you can't go -11, but you can go -10. And Hedayat and me start a transaction, right? And I see Hedayat's count and he has 0. Okay, 0. And he wants to send me 5 credits. Okay, all good, like he has 0, 5, like let's begin the transaction. Imagine if there was no locking. I am signing the entry, like Hedayat is giving me 5 credits. I am not signing at which point in time we are doing that. I'm signing like in my time, but not in Hedayat's time, right? So what Hedayat can do is get the signature that I signed, and then in background do the same with a transaction of 6 credits, and the transaction with just goes first, and then I look like the bad guy because I signed a thing that made Hedayat -11. I look like the bad guy, right? If instead you lock, you're saying, no, I'm just committing to do the -5 with Hedayat. At this point, like if Hedayat is at header number 3, I commit. If Hedayat would be at any other number of header, I don't know. I have to check, right? Did that make sense?
Thank you. Great. If still it is confusing, don't worry. For any reason, I think later on we can also make it more clear with some design. So,
wait, interestingly, just a story. If you remember the mutual credit experiment we did last year, I spent a whole, not a whole week, but the most part of 1 week. What can we do to do transactions in multiple sourcing? This was in Holochain Redux, and I ended up in the exact same place, like having the header hashes and signing the header hashes. So when I looked at the implementation that the Holochain core did, I was like, yes, this at least this you have to do.
that is great. Quick review, let's go and see again. We already saw if the whole process is supposed to be finished as accept. What happened if again you want to ask me something to sign or a transaction, I'm going to reject. Can you please show us to see how the reject process is working?
Okay, can you see this? Cool. So what happens if Bob rejects? Right, so beginning is exactly the same, but then Bob replies, nope, I'm mad at you, right? In this case, Alice has a bad time because Alice locked her own chain, but now she can't commit anything here because she didn't get the signature from Bob, and she committed herself to not commit anything else on the transaction, right? So basically, she has to wait for the session timeout. and that will automatically unlock. This is the way it is right now. In the future, maybe Holochain Core will implement some kind of manual unlock in which you hear, if you know that the transaction is not going to go through, you can unlock, right? And this is to the point actually that locking your chain is not really what? Let's say a security feature that can be hacked by others. It's really yourself. You are not allowing yourself to cheat, right? The locking of the chain could be cheated by a bad agent, right? The same as a bad agent can have different validation rules. A bad agent can not lock their own chain if they want, right? This locking of the chain is something private that I want to do to prevent myself from cheating, right? So this lock of the chain is nothing published, is everything stays private. And this is the reason why we can do manual unlock if needed in the future here.
Mm-hmm. The topic mentioned, Guillaume mentioned, is a little bit advanced. I think let's open it later, Guillaume.
Sure.
So, but all in all, right now, during the process, if Alice sends something and Bob, for any reason, for example, Bob can query DHT and asking for something, make a decision and say, hey, Alice, I'm not okay with your process, with your Elo, with your transaction, with your contract is not fair, blah, 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 any scenario. Sorry, I'm not in. Bob would receive null answer or bad answer or any answer, non-agreement. So it means Alice is not going to publish anything in DHT. Right now, we don't have unlock to call it. Alice is supposed to be waiting that the session is going to be finished and then everything is going to be forgotten. So in that case, it means we already don't have any commit or roll back the transaction that we can say manually just finish it. So for sure, it's going to get more mature, I believe, for the later on. So that's being said, and again, because I think we covered it a lot, maybe we can say the code review another time, or what do you think? I think a lot, and still one thing is remain, because we changed the title and the names to make it sugar titling or good understanding. If also can Guillaume explain us the title that we show in the diagram, sequence diagram, mapping to the HDK, I think it would be good enough that we explain you how generally countersigning is working, why we need blah, blah, and we can go on a code review for another time. With maybe it is fantastic mixing and another time. I believe it would be fantastic.
It's like our brains have telepathy. Yes, I agree totally. So what I am going to do is have this here and open up.
Again, can we have access to this HackMD? Can I share in the description with people?
Yeah. Publish. Yeah. I'll send it. So yes. Cool. So
again, by the way, the bar of the speakers, like always, a zoom. So this is the black bar. If you can minimize your speakers. Go. Yes. But it went. Oh, that is amazing. Go.
Thank you. Okay, let's see. Cool. So this is the mapping of colloquial names that we used and the actual name in the documentation. So locking your chain is actually accept countersigning pre-flight request. I'm now realizing that I should have done pre-flight request first. So let's do that first. So pre-flight request is here, right? And this is really basically the entry and session info together, right? This is the, and hey, we are going to commit this entry, and these are the agents that are going to commit it, nothing more. This doesn't contain the signatures, right? Then the pre-flight response is the request plus the signature of a request for an agent, right? And the process to sign a request to get the signature is accept countersigning pre-flight request. And now at least the name makes a bit more sense, right? But this is actually locking your chain, right? So if I go here to accept countersigning pre-flight request, locks the chain to commence a countersigning session. This function must be called by every signer in the signing session, right? And then, yeah, and then I don't think this is necessary. What do I did? I don't know. What did I? No, there isn't. These types are not really necessary. Oh, wait. Yes. Hidayat, is it okay if I show just 10 lines of code of how do you build a countersign entry, like the data structure?
If you think it's useful, please go ahead.
So build game result pre-flight. This is from the entry contents. How do you build this pre-flight, which is the entry plus the session info or whatever. So pre-flight request is a type in Holochain, right? And it's interesting because you have to have this kind of header base, right? Which there are two header bases, create base or update base, right? And the idea is that the only thing that can be created while countersigning is a create header or an update header, right? And then here you say the agents that are going to be countersigning this, and here you bundle everything up. Does this make sense? This is the last part of the API that we didn't see.
Yes, yes, that is great.
Okay, cool. Any questions? Otherwise, I feel complete. Like there is quite a bit of stuff here, but actually you don't need it most of the time.
Yeah, I have a question that I think it's somewhat out of the scope of what we're talking about, but I'm interested in nonetheless. Is there some kind of request queue that can be set up so that when a source chain is locked, all these write requests aren't just rejected, but they kind of stack up and are processed when a chain is unlocked?
Right, that's a good question.
We don't have to get into it right now. I'm just kind of curious if something like that exists.
Yeah, just a one-liner. Right now, you can't do that.
No queuing.
Because
Okay.
if you are locked, you can't commit anything else, right? In the future, we are going to get something called ephemeral store in Holochain, which is a place for you to store data without it being persistent in the source chain. So in theory, it should be possible there to do the queue.
Cool, thanks.
Anything else? I think that's it.
Countersigning. So
check one topic less in the 1,000 topics that we have to.
Yes. So fundamentally, it would be fantastic that we could have enough time to also see the code, but a lot of content doesn't work generally step by step. I'm really happy that we could cover and we could see the whole content of countersigning, why we need it, like always, social fabric We go to the reality to see what's happening. And luckily, we have this concept also in Holochain. For sure, I'm sure after a while, it's going to get much more mature, much more extra functionality. But anything can be more or less, but the whole concept is this one. It means you as a developer supposed to have a process for two sides, or n people can, or x people can go and sign something. That's it. We have it right now. Like always, DM, great job. Thank you, thank you, thank you, and we love you. Fantastic. And for another session, we are going to code review this one specifically because there is another beautiful topic like a mixing that you saw. Feel free to go and code review, but generally a beautiful, nice topic. We are going to also explain using this countersigning example, which is mixing. I'm totally inviting you to just join too. It was a fantastic topic. Thank you for watching. Looking forward to see you if you would like to be here and share something, pair programming and etc. And we love you. Take care. Bye-bye.